Hello, everyone. Welcome to Soft Science. Tonight, we will talk about something that might stretch your mind far beyond the edge of what feels possible. We're going to ask, is the future out there in the universe somewhere? As you begin to relax and settle in for the night, let this question drift gently through your imagination. Could it be that the future already exists, waiting to be reached? Or is it simply a blank canvas, forever forming moment by moment? From the moment we're born, time feels like something we're moving through. Seconds pass, then minutes, then years. The past feels solid. It happened. The present feels immediate. We're in it. But the future, it's elusive. It hasn't happened yet. Or has it? In this episode, we'll explore what physics, cosmology, and philosophy suggest about the reality of the future, and whether, deep within the structure of the universe, the future is already there, just as real as the past and the now. Let's begin with how we experience time. To us, time flows. You wake up, the sun rises, you eat, sleep, grow older. There's a clear order to it all. But physics tells a stranger story. According to Einstein's theory of relativity, time doesn't flow the way we think it does. Instead, time is more like space. It's a dimension, not a river. Just as all points in space exist simultaneously, relativity suggests that all points in time might exist as well. This idea leads to a mind-bending concept called the block universe. Imagine the universe as a giant, four-dimensional block. In this block, every moment, past, present, and future, coexists. Nothing is really becoming, it just is. Your birth, your last birthday, and your next conversation already occupy fixed positions in this block, even if you haven't experienced them yet. In this view, the future isn't something that happens later. It's already laid out, like the rest of the road on a map you just haven't driven yet. But if the future already exists, why can't we access it? Well, we're not moving through time the way a car moves through space. According to the block universe, your consciousness, your perspective, moves through these points, giving you the illusion of time passing. You experience one slice of the block at a time, like viewing one frame of a film strip while the rest remains hidden. So when we ask, is the future out there? One answer is yes. It's just in a slice of space-time we haven't visited yet. Now, let's talk about determinism, another concept that gives weight to the idea that the future may already be fixed. In classical physics, if you know the precise position and velocity of every particle in the universe, you can, in theory, calculate its future. That was the idea behind what's called Laplace's demon, a hypothetical intellect that could, if it had enough information, predict the future with perfect accuracy. That sounds mechanical and rigid, and yet it aligns with the idea of a future that's already set. It implies that the universe is like a grand clockwork, ticking toward an outcome that was baked into the starting conditions. In this worldview, the future already exists in the same way a planted seed already contains the blueprint of a tree. The unfolding is inevitable. But physics got a lot weirder in the 20th century. Enter quantum mechanics, a realm where probability, not certainty, rules. Here, particles don't have a definite position or speed until they're observed. Until then, they exist in a superposition, a kind of cloud of possibilities. And when you observe them, they collapse into one outcome. This raises a powerful question. Does the future exist as a cloud of possibilities, only solidifying when it becomes the present? Or does it already exist in all its variations, waiting to be selected? Some interpretations of quantum mechanics, like the many worlds interpretation, suggest that every possible future does exist in separate parallel universes. In one future, you become a painter, in another, a scientist. In yet another, you're doing exactly what you're doing right now, but with a different thought on your mind. These are all real in the sense that they exist in a vast quantum multiverse. In that case, not only is the future out there, but all futures are. That's a different kind of existence. It's not a single road, but an entire network of roads, all branching off from every moment. Let's also consider light and how it plays into our understanding of time and space. When we look at distant galaxies, we're seeing them as they were millions or even billions of years ago. Light takes time to travel. That means, in a real way, the past is visible in the present. But is the future visible too? There's a strange symmetry in the laws of physics. Many of the equations that govern particles and forces don't care whether time moves forward or backward. This time, symmetry suggests that the future is just as embedded in the structure of reality as the past. In fact, some physicists have experimented with equations where the future influences the past, called retrocausality. In these models, events in the future can shape what happens now. It's still a controversial idea, but it pushes us toward the notion that the future might already exist in some fundamental way. Another clue comes from gravitational waves, ripples in space-time itself, produced by massive cosmic events like colliding black holes. These waves travel through the universe, carrying information across time. Could future events create ripples we haven't felt yet? Could space-time be buzzing with signals from things that haven't happened from our point of view? We also have to think about entropy, the tendency of systems to move from order to disorder. Entropy increases over time, giving us what we call the arrow of time. But entropy doesn't prevent the future from being real. It just marks which direction we're facing. Like walking forward through a foggy landscape, you can't see what's ahead, but that doesn't mean it isn't already there. In the deepest sense, the laws of the universe don't forbid the future from existing. They may actually require it. Some theories suggest that the very structure of the universe makes no distinction between past and future, only our experience does. Even our consciousness may be involved. Some physicists and philosophers argue that our sense of now is a construction of the brain, not a property of the universe. The brain stitches together sensory inputs and memories into a flowing narrative. But in the raw math of physics, there is no now. There's only the entire block, every moment, every possibility, every outcome. So where does that leave us? Perhaps the future is already written in invisible ink. We can't read it yet, but it's there, waiting for light to pass through and make it visible. Or maybe the future is a sea of shimmering probabilities, and only when our attention arrives does one of them solidify. In either case, the question remains a thrilling one. Is the future truly out there in some distant corner of space-time, as real as your first memory or the breath you're taking now? As we explore this further, we'll look at the nature of time more deeply, examine how physicists are trying to test these ideas, and journey through space and mind to see if the future might already be closer than we think. For now, rest easy, knowing that time, past, present, and perhaps even future, may be far stranger and far more beautiful than it seems. Let's return to the idea of time as a dimension, something that exists all at once, even if we only experience it one moment at a time. The block universe idea we explored earlier implies that your entire life, every thought, every breath, every decision already has a place in space-time. You are simply experiencing one slice of that reality, moving through it like a flashlight scanning over a film reel. If this is true, then the future isn't something we're waiting for. It's something that already exists, waiting for us. Now, consider this. Why do we only remember the past and not the future? If all of time exists equally, why does memory point only backward? This is one of the great mysteries of consciousness. Some scientists suggest that memory is simply a product of increasing entropy. The brain stores experiences from lower entropy states because they help us survive in higher entropy environments. In other words, we remember the past because it's useful, but that doesn't mean the future doesn't already exist. Interestingly, physics doesn't prohibit the idea of future memory. In fact, some experiments in neuroscience and psychology have shown hints, however controversial, that people sometimes behave as though they sense events before they happen. These are called presentiment experiments. While far from conclusive, they raise curious questions. Are we, in some way, brushing against future information without knowing it? If we entertain the idea that time is not a strict line, but more of a spatial landscape, then memory and awareness might simply be tools for navigating it, and our inability to remember the future may not be due to its absence, but due to the design of our biological machinery. Another way to look at this is through the lens of causality, the idea that causes led to effects, and not the other way around. Causality is one of the main reasons we feel the future hasn't happened yet. If dropping a glass causes it to shatter, we say the shattering is in the future. But causality might be a property of our perception, not of reality itself. In physics, there are theories in which the equations work just as well if time runs backward. If you ran the video of a glass reassembling itself and leaping back into a hand, the math still checks out. It's only our experience of time and of increasing entropy that makes it feel unnatural. This leads us to a deeper idea. Time asymmetry might not be built into the laws of the universe. Instead, it could be a feature of our position within it, like seeing a mountain from one side and assuming it's a wall, when from another angle, it's clearly a peak. Let's now bring in the strange world of quantum physics again. When you observe a quantum particle, it collapses into a single outcome, but before that, it exists in a cloud of possibilities. And here's where things get really interesting. There are experiments that seem to show particles choosing a path based on measurements that happen after they've already traveled. These are called delayed choice experiments. In them, particles behave differently depending on whether or not they're observed. But that observation happens after the particle should have made up its mind. It's as if the future measurement reaches back and alters the past behavior. This isn't science fiction. These experiments have been performed, and they seem to suggest that the boundary between past, present, and future is much more flexible than we assume. If future events can affect past behavior at the quantum level, it opens the door to the possibility that the future exists in a very real way. Let's take that idea a step further. Some physicists and philosophers have proposed the concept of temporal non-locality, a fancy way of saying that events in time might be entangled in the same way that particles can be entangled across space. In quantum entanglement, two particles become linked so that no matter how far apart they are, their states remain connected. Change one, and the other reacts instantly. What if moments in time were entangled in a similar way? What if your present and your future are already linked, like two sides of a coin, and it's only your perception that separates them? It sounds mystical, but it may just be the next frontier of physics. Some researchers are even working on quantum time crystals, a theoretical state of matter that exhibits movement in time without energy. These structures don't evolve from past to future. They just cycle endlessly in perfect symmetry. In such systems, time itself behaves like space, a repeating loop, not a one-way street. This pushes us toward the question of how reality is constructed. Could time be a byproduct of consciousness? Some interpretations of quantum mechanics suggest that reality doesn't fully exist until it is observed. If that's true, then the future may be less like a destination and more like a projection, waiting to be rendered by attention. The observer effect in quantum mechanics tells us that observation changes outcomes. This may also be true of time. Maybe your act of witnessing the present is what collapses the future into form. In this sense, the future exists as a cloud of all possibilities, and your conscious attention draws one strand of it into existence. So is the future out there in the same way a distant star is? Or is it more like a seed in the soil, already formed but waiting for your gaze to help it bloom? There's also the philosophical notion of eternalism, which holds that all points in time are equally real. This idea suggests that the past and the future are just as real as the present, just located in different positions along the temporal dimension. It's like saying that all places on a map exist at once, even if you're only standing in one. Compare this to presentism, which holds that only the present is real. Eternalism is much more in line with modern physics. Spacetime models assume that time is just another coordinate. That makes the future a location, not a possibility. If eternalism is true, then the future isn't just a concept, it's a place, a real part of the universe's structure. And if that's the case, then in some sense, you've already arrived there. But how can we ever know? Right now, we are bound by our biology and limited to experiencing one moment at a time. Our eyes see a narrow band of light. Our ears hear a narrow range of sound. Our minds process a sliver of time. But imagine a being not limited in that way, one that could see the entirety of the block universe at once. To such a being, the future wouldn't be hidden. It would be just another part of the cosmic panorama, laid out like a landscape. From their perspective, your future already exists. Every choice, every conversation, every discovery, shining like a constellation, just waiting to be perceived. What we experience as unfolding may just be our consciousness walking through a garden that's already in full bloom. If the future is out there, already written into the fabric of the universe, then it's natural to ask, could we ever visit it? Time travel has long been a staple of science fiction, but it also has a surprising presence in serious physics. While traveling to the past raises all sorts of paradoxes, many physicists agree that traveling to the future is, in principle, allowed by the laws of nature. Einstein's theory of relativity provides a doorway. According to special relativity, time slows down as you approach the speed of light. This phenomenon is called time dilation. It's not theoretical. It's been confirmed by precise experiments using fast-moving particles and even astronauts orbiting Earth. If you were to travel near the speed of light in a spaceship and then return to Earth, you would have aged far less than the people who stayed behind. For you, only a few months might have passed. For them, decades. This means you could effectively leap into the future. You couldn't come back, but you would have moved forward in time, leaving your original present behind. From your perspective, you simply took a long trip. From Earth's perspective, you disappeared into the future. This is more than just a curiosity. It tells us something fundamental about time. It's not universal. It bends, stretches, and shifts depending on how fast you're moving and how deep you are in a gravitational field. Time is flexible, and that flexibility could, in some cosmic sense, point toward a future that is physically accessible. Let's explore another time machine, not one that relies on speed, but on gravity. General relativity tells us that massive objects warp space and time. The stronger the gravity, the slower time moves. This is known as gravitational time dilation. Near a black hole, time slows down dramatically. The deeper you go into the gravitational well, the slower your clock ticks relative to someone far away. In the movie Interstellar, this concept was portrayed when an hour on a distant planet equaled years on the spaceship waiting above. That may sound like fiction, but it's scientifically accurate. This opens another doorway to the future. If you hovered just outside the event horizon of a black hole and then returned to Earth, far more time would have passed here than for you. Again, you would have traveled into the future without ever exceeding the speed of light. So the question is no longer if future travel is possible. The question becomes, what does that tell us about the nature of time? If the future were not real, if it didn't already exist in some form, then how could time dilation make sense? How could you skip forward into a moment that hasn't yet been formed? This is one of the most powerful clues we have that the future might already be embedded in space-time, simply waiting to be reached through extreme motion or gravity. But what about the cosmic scale? Let's zoom out, far beyond Earth, the solar system, and even our galaxy. The universe is expanding. Not only that, it's expanding faster and faster. This accelerated expansion creates what physicists call cosmic horizons, limits to how far we can see or influence. Because light takes time to travel, looking into the distance means looking into the past. But the farther you look, the more you see galaxies speeding away from us, redshifted by the expansion of space. Some of them are moving away so fast that their light will never reach us. They are, in a sense, slipping into the unreachable future. From our vantage point, the observable universe is like a growing bubble. What lies beyond its edge? The rest of the cosmos. Galaxies we will never touch. Events we will never witness. But they are still happening. Their future is unfolding, even if we'll never experience it. This cosmic horizon acts like a temporal curtain. Beyond it, the universe is evolving, aging, transforming. That future exists. We just can't catch up. And here's the twist. Someone else, far away from us, might be watching us vanish into their past. Our light stretched so thin that we become invisible. In this way, future and past become relative, depending on where you stand in the cosmos. So we must ask again, is the future a single thread stretching forward? Or is it a woven fabric, already in place, waiting to be touched from different angles? There's another theory worth considering, one that pushes the boundaries of imagination: the multiverse. Some versions of the multiverse suggest that every possible future exists, not in time, but in parallel. Each decision, each quantum outcome, creates a branching timeline. In this view, the future isn't a single line ahead. It's a vast landscape of possibilities, all unfolding simultaneously in different branches of reality. When you choose one path, you collapse into a version of the future, but the others still exist, running alongside you like unseen tributaries of time. This idea is supported by interpretations of quantum mechanics, particularly the many-worlds interpretation, which proposes that every quantum event creates a split in the universe. If that's true, then the future isn't just out there, it's everywhere. An infinite web of potential outcomes, already written into the structure of the multiverse. And yet, from your perspective, you only experience one. So what does that say about consciousness? Could it be that your awareness is what chooses the path? That your attention, like a beam of light, collapses the wave of futures into a lived experience? We begin to approach not just physics, but metaphysics. Let's revisit relativity one last time. When physicists map the universe using Einstein's equations, they don't draw a timeline. They draw a space-time diagram, a four-dimensional structure where all events are laid out in relation to each other. In these models, there is no objective now. There is no master clock ticking through the cosmos. Every moment is equally real. Every event already has a place. This is called the block universe, and it's one of the most widely accepted implications of modern physics. In a block universe, your future self is just as real as your current self. They are part of the same structure. You just haven't reached that part of the block yet. But, and this is important, just because something is fixed in the block doesn't mean it's predictable to you. The future may be set from a cosmic point of view, but from your limited perspective inside time, it remains full of mystery. And that mystery gives rise to meaning, to choice, to wonder. So when you ask, is the future out there in the universe somewhere? The scientific answer may very well be yes, but it's not just out there like a distant planet. It's also here, encoded in every law of nature, written into the space-time we live inside. A hidden landscape your consciousness is constantly moving through, whether you know it or not. To truly understand the future, we must first understand something fundamental: the arrow of time. Time, as experienced by humans, seems to flow in one direction, from past to future. We remember yesterday, but not tomorrow. We age, but we don't become younger. Causes come before effects. This forward motion of time feels so intuitive, so built in, that we rarely question it. But here's the strange thing. Most of the fundamental laws of physics don't care about direction. Newton's equations, Maxwell's laws, even the Schrödinger equation in quantum mechanics, all are time symmetric. That means they work just as well if you reverse the flow of time. If you filmed a billiard ball bouncing off another and played it backward, it would still obey the laws of motion. Nothing would seem out of place. So where does the arrow of time come from? The answer lies in entropy. Entropy is a measure of disorder. More specifically, it's a measure of how many possible arrangements a system can have. A glass of ice water, for example, has lower entropy than a lukewarm puddle of water, because the structured, low-energy ice is more ordered than the mixed, room-temperature liquid. The second law of thermodynamics says that in a closed system, entropy tends to increase over time. Things naturally move from order to disorder. This is why ice melts, why buildings crumble, why stars burn out, and why memories fade. This tendency toward increasing entropy is what gives time its direction. It's the one feature in physics that distinguishes the future from the past. In other words, the future is the direction in which entropy increases. This insight is both profound and humbling. It means that the flow of time, the one-way street we live on, is not built into the universe at the deepest level. It's an emergent property, arising from the statistical behavior of countless particles. So what does this tell us about the nature of the future? If time's arrow emerges from entropy, then the future may not be a destination waiting for us. Instead, It may be the path of increasing disorder, unfolding step by step. But then we hit a paradox. When we look at the early universe, just moments after the Big Bang, we see something surprising. It was incredibly hot, incredibly dense, and yet incredibly ordered. This flies in the face of expectation. If the universe exploded into chaos, you'd expect it to start with high entropy. But it didn't. It started low. And because it began in this rare, low entropy state, the universe has been increasing in entropy ever since. Stars have formed and burned. Galaxies have merged. Black holes have devoured matter. All of this is entropy at work, creating complexity and giving us the illusion of time flowing forward. So why did the universe start in such a low entropy state? That question remains one of the great unsolved mysteries of cosmology. Some physicists speculate that it's simply a boundary condition, a fact baked into the fabric of the cosmos. Others believe it hints at a deeper symmetry, perhaps even a mirror universe on the other side of the Big Bang, where time flows backward. But regardless of the cause, the result is clear. Because the universe started in a state of low entropy, it's been moving steadily toward higher entropy. And we, as conscious observers, are riding that wave. We are creatures of entropy. Everything about our perception, the ticking of a clock, the aging of our bodies, the sequence of memories, is tied to the increase of disorder around us. It's like a cosmic current, pulling us toward what we call the future. But now imagine this. What if, on a deep level, all of time already exists? Past, present, and future. And our conscious experience is simply moving along a line, like a needle on a record. If that's true, then the future isn't something being created. It's something already there, waiting to be passed through. Entropy wouldn't create time. It would merely mark our movement through it. This returns us to the block universe, a view of reality in which all of space-time exists as a single, unchanging structure. The past is still there. The future is already there. You are simply located at one slice of it, like a flashlight beam illuminating one frame of a film. And entropy, it's just the shape of the trail your beam follows. Let's return to a more human scale. When you wake up tomorrow morning, you'll think of the day ahead as a blank canvas. But according to physics, that canvas may already be painted. You simply haven't seen it yet. Is that fate? Is it determinism? Not necessarily. Even if the future exists in some form, it doesn't mean it's predictable or preordained. Quantum mechanics ensures that uncertainty is baked into the very act of observation, and consciousness, whatever it is, seems to surf that uncertainty, collapsing possibility into lived experience. This suggests a profound truth. The future may already exist, but you still play a role in shaping which version you step into. Like a quantum traveler, your choices may direct the beam. You don't create the movie, but you do choose the frame you move into next. In this way, science brings us back to something that feels almost poetic. You are not a prisoner of time, but a participant. Not just a passenger on the train, but perhaps, even in a small way, a conductor. The arrow of time will continue, pulled forward by entropy. The stars will burn out. The universe will cool. But in this fleeting moment, this unique intersection of order and awareness, you get to witness the unfolding of the future as if it was something new. And maybe, just maybe, it is. So far, we've explored relativity, entropy, and the idea of the block universe, all suggesting that the future might already exist in some form. But now we arrive at a frontier even stranger. the quantum world. At the quantum level, reality doesn't behave in neat, predictable ways. Particles exist in superpositions. Their positions, speeds, and even identities seem fuzzy, undefined until measured. This fuzziness introduces what appears to be fundamental unpredictability into the universe. But here's the puzzle. If quantum outcomes are truly random, how can the future be fixed? In classical physics, determinism reigns. If you know the starting conditions of every particle, you can, in theory, calculate the future. But quantum mechanics throws a wrench in that machine. Even with perfect knowledge of the present, quantum rules say you can only predict probabilities of future outcomes, not certainties. Roll the quantum dice, and you get different results each time. This uncertainty seems to break the idea of a future that's already there. But not so fast. Enter the many worlds interpretation. This interpretation doesn't say the future is uncertain. It says every possible future happens. Every time a quantum choice is made, reality splits. In one branch, the particle goes left. In another, it goes right. In yet another, it vanishes and reappears. Each of these futures is real. They exist in parallel, part of a vast multiverse of outcomes, all stemming from a single moment of probability. In this view, the future isn't undefined. It's infinitely defined. All futures already exist. You're just experiencing one. This idea changes our question. Instead of asking whether the future is out there, we might ask, which future? And if all futures exist, how does your consciousness navigate them? Some physicists and philosophers suggest that the act of observation, of attention, helps select which path you follow. Like tuning a radio, your awareness collapses the field of possibility into a specific track of experience. This doesn't mean you control the future directly, but it may mean that your presence, your choices, your awareness play a role in which already existing future becomes your lived reality. Let's explore this through another idea: future boundary conditions. Most of physics focuses on initial conditions. We know how things start, and from that, we try to predict what comes next. But what if some systems are also shaped by their final conditions? This concept appears in certain equations of physics, where both the beginning and the end influence what happens in the middle. That means future states can, in some sense, influence the present. It's a controversial idea, but it suggests a two-way street. Just as the past flows into the present, the future might too. In some interpretations of quantum mechanics, such as the two-state vector formalism, events are determined by both past and future boundary conditions. The present becomes a meeting point between what has been and what will be. It's as though your current moment is suspended between two cosmic shores, the past pushing you forward, the future pulling you in. If that's true, then the future is not just out there, it's active. It's reaching back, shaping your now. This concept also appears in retro-causality, the idea that causes can come from the future, not just the past. This isn't mainstream physics, but it's being studied in serious academic circles. And in certain experiments, particles seem to behave as though they're influenced by measurements that haven't happened yet. While this doesn't give us a time machine, it hints at a deep symmetry in time, one in which the future plays just as important a role in shaping events as the past. So how would we even know if the future exists? One clue might be in information. In physics, information can't be destroyed. Black holes, once thought to obliterate information, are now believed to encode it on their surfaces, like cosmic hard drives. This preservation of information suggests that every event, past, present, and possibly future, leaves a kind of imprint on the universe, like fossilized waves rippling through space-time. If we could decode those patterns, perhaps we could read the traces of things that haven't yet unfolded. This idea appears in holographic theories, where the entire universe is thought to be a kind of projection, three-dimensional space emerging from encoded information on a two-dimensional surface. In such a universe, the future may already be written in the quantum code of reality. We just haven't decoded that part yet, and this raises the most poetic possibility of all. Perhaps the future isn't waiting in front of us, like a road we haven't walked. Maybe it's already present, folded into the shape of the now. Perhaps it's there in the structure of light, in the hum of atoms, in the curvature of space-time, hiding in plain sight, like a song we haven't yet heard but is already etched into the vinyl. So is the future out there in the universe somewhere. From what we've seen so far, from relativity, quantum mechanics, information theory, and beyond, it might be. It might be in the structure of space-time, in the quantum foam, in the coded fabric of the cosmos. It might not be something we create, but something we encounter, frame by frame, moment by moment, as our consciousness moves forward through an already written story. And maybe, just maybe, it's not fixed in a single form, but branching and infinite, allowing you to step into the version that matches who you choose to become. If the future already exists somewhere in the fabric of the universe, then what keeps us from seeing it? And more curiously, are there cracks in that barrier? Let's begin with something subtle and elegant in physics. Time symmetry. Many of the core equations that govern reality, like Newton's laws, Maxwell's equations for electromagnetism, and even Schrödinger's equation in quantum mechanics, are time reversible. That means they work just as well forward as backward. Imagine watching a film of two billiard balls colliding. In reverse, the scene still makes sense. The physics still holds. But our everyday experience tells us time only flows forward. We remember the past, not the future. We age, not de-age. Entropy increases. This discrepancy between the mathematical symmetry of time and our one-way experience of it is one of the biggest puzzles in physics. It suggests that, at a deep level, the future is just as real as the past. We just have asymmetric access to it. But why? One explanation lies in thermodynamic irreversibility. The universe began in a state of extremely low entropy, and it's been climbing ever since. That gradient, from order to disorder, gives us a direction, the arrow of time. But that arrow may be a local illusion, a consequence of initial conditions, not a fundamental law. And if that's true, time might not be a one-way street at all. This opens the door to stranger possibilities. Could some information from the future be leaking into the present? This idea, while controversial, appears in scientific literature under the term advanced waves, waves that propagate backward in time. In standard electromagnetism, we mostly consider retarded waves, those that travel outward from a source into the future. But the math allows for advanced solutions too, where waves travel into the past. These advanced waves are usually ignored because we don't observe them. But some physicists, like John Wheeler and Richard Feynman, suggested that all electromagnetic interactions might involve both advanced and retarded waves. In their model, an interaction in the present involves a handshake between past and future. A signal leaves one particle and is absorbed by another, not just forward in time, but backward too. The transaction is timeless, a completed loop. This idea leads to an astonishing notion. The future may be influencing the present right now through hidden transactions that lie beneath our conscious awareness. It's not just theory. There are puzzling quantum experiments, like the delayed choice quantum eraser, where actions performed after a particle has passed through an apparatus appear to affect its past behavior. It's not that the particle knows the future, but that the future measurement seems to retroactively define what happened earlier. Physicist Yakir Aharonov and colleagues have taken this idea further. In their two-state vector formalism, a quantum system isn't fully described by its past alone, but by both its past and future boundary conditions. In this view, the present is not just the result of the past, it is shaped by the future too. But can this idea go beyond physics and touch human experience? Throughout history, people have reported spontaneous visions, dreams, or intuitions that appear to reveal future events. These are often dismissed as coincidence, but scientific interest in precognition has quietly persisted. Studies in parapsychology, though highly controversial, have suggested small but statistically significant evidence that people can respond to stimuli before they occur. One famous example is the presentiment experiment, where participants' physiological responses, like skin conductance or heart rate, change moments before being shown emotional images, even when the sequence is randomized. It's not proof, but it challenges our assumptions about time and causality. Could we be receiving subtle signals from the future, but simply not aware of how to interpret them? One hypothesis is that our brains function like temporal filters. They interpret reality in a forward-flowing sequence because that's how we survive best. Cause and effect, decision and consequence. But underneath that filter, the full picture of space-time may already include future influences, nudging us gently, whispering in dreams, sparking gut feelings. If the brain is sensitive to quantum processes, as some theories of consciousness propose, then perhaps it occasionally picks up fragments of a future already present in the block universe. In physics, the path integral formulation developed by Richard Feynman suggests that particles don't take just one path from point A to point B. Instead, they take every possible path, and only when all paths are considered does the outcome become what we observe. This idea echoes into the larger question of time. Perhaps our lives too involve all potential futures, and what we call now is just the point of convergence, the most probable path that results from the sum of all that might be. This would mean the future isn't just out there, it's here, in the math, in the code, in the waveforms that ripple across the fourth dimension. We don't see it clearly because we're inside the equation, but once in a while something leaks through, an idea that arrives too early, a hunch that proves correct, a moment of déjà vu, a technology imagined decades before its time. In speculative physics, some researchers have proposed closed time-like curves, paths through space-time that loop back on themselves. In certain solutions to Einstein's equations, like Gödel's rotating universe, such loops are possible. These structures suggest a reality where time is not linear but curved, where future and past can be entangled in ways we've only begun to imagine. And if that's the case, then the future may already be folded into the fabric of now. It's not waiting at the end of a tunnel, it's woven into the tunnel walls. So when we ask, is the future out there in the universe somewhere? The most astonishing answer might be, yes, and you're touching it all the time. Every decision you make, every thought you hold, every observation you conduct might be entangled with what's to come. Not in a way that removes your freedom, but in a way that links your choices to a deeper unfolding. You are not moving toward the future, you are unwrapping it. If the future is already written into the universe, etched like ink into a four-dimensional canvas, then what about causality? Can effects precede causes? Can information travel from tomorrow into today? These are not just philosophical questions, they're active topics in physics. Let's begin with causal loops, a hypothetical sequence of events where the outcome becomes its own cause. Imagine a scientist who builds a time machine after reading a blueprint she mysteriously received. She then travels back in time and gives that blueprint to her younger self, who grows up to build the machine. Where did the blueprint come from? It wasn't created by either version of the scientist. It exists in a self-contained loop. While this seems paradoxical, it's not necessarily ruled out by the laws of physics. Certain solutions to Einstein's general relativity equations, such as those involving rotating black holes or wormholes, allow for closed time-like curves. These are paths through space-time that loop back on themselves. If such loops exist, they could permit the transmission of information, and even matter, between future and past. This introduces a bizarre but mathematically plausible form of retrocausality, where future events affect the present. In quantum mechanics, retrocausality has gained increasing attention. It offers one explanation for the puzzling results of experiments like the delayed choice quantum eraser, where the outcome of a measurement seems to depend on a future decision. Some physicists argue that rather than imagining particles choosing paths based on what happens later, it might be simpler to say that the future measurement causes the particle's earlier state. It's not that cause and effect are violated, it's that causality itself may be bidirectional at the quantum level, like tension on both ends of a rope rather than a push from one side. In fact, a growing number of physicists propose that time itself may be emergent, not fundamental. That is, time could arise from more basic relationships or correlations between quantum events. In this view, time isn't something that flows. It's something that emerges when information is processed in a particular order. Imagine watching a flipbook animation. The images themselves don't move, but when viewed sequentially, they create the illusion of motion. Time, in this analogy, is the result of how your brain organizes the still images. Could the universe be doing something similar? This leads us to the idea of the holographic principle, the notion that the 3D world we experience is a projection of information encoded on a distant 2D surface. In such a reality, space and time may both be illusions, useful but not fundamental. If time is emergent, then the future could already exist, just not yet unwrapped in our local frame of reference. Think of a DVD. The entire movie is encoded on the disc, but you only experience the scenes one frame at a time, in order. The future scenes already exist on the disc. You just haven't reached them yet. Likewise, your personal experience of the future may be constrained by the speed of information processing, the order of events, and the thermodynamic arrow of time. But in the grand view, the universal DVD, the whole timeline might already be there. This brings us to an even deeper question. If the future already exists, can we change it? The answer depends on how you interpret quantum mechanics. In the standard Copenhagen interpretation, the future isn't fixed until it's observed. It exists only as a cloud of probabilities. But in the many worlds interpretation, every possible future outcome already exists in a branching multiverse. Each time you make a decision, reality splits. In one version, you turn left, in another, right. Each version continues independently, with its own unfolding timeline. So the future exists not as one inevitable road, but as an ever-branching tree. You don't travel to the future, you grow it. This view allows for both a fixed future and free will. The entire tree exists, but you still choose which branch to walk. In physics, this is echoed in Feynman's sum over histories, a framework in which particles take all possible paths through spacetime, and the path we observe is the sum of all these histories. The path exists in totality, but we only perceive a slice. Now let's return to our core question. Is the future out there, waiting in the fabric of space-time? If we embrace the block universe model, then yes, it's already part of reality, just like the past. But if we lean into interpretations where time is emergent, the answer is more nuanced. The future may not be fixed in the way the past seems to be. Instead, it may be a superposition, a range of possible outcomes that become definite only when conditions, choices, and quantum events converge. Some physicists call this temporal becoming, the idea that the future crystallizes into the present, moment by moment, like ice forming on a lake. In this metaphor, the universe is a wave of potential, and our experience of time is the moving edge, where probability collapses into certainty. You might ask, what is the practical use of these ideas? They invite a profound shift in how we understand our place in the cosmos. If the future is already real, then we're not separate from it. We're embedded within it. Every thought, every action, every moment is a stitch in the fabric of a future that already exists in potential. Understanding this could change how we view our decisions, not as meaningless motions toward an unknown outcome, but as quantum selections among real possibilities. It also suggests a curious form of connection. You may already be entangled with your future self. Your hopes, instincts, and inner guidance could be more than imagination. They might be echoes from a timeline you're already stepping into. This idea is echoed in quantum cognition, a field that applies principles of quantum theory to human thought. Some researchers suggest that the mind doesn't operate like a deterministic machine, but like a quantum system, processing possibilities in parallel, collapsing into action only at the moment of choice. In this framework, the future isn't just ahead of you, it's within you. It's not a destination you reach, it's a resonance you align with. The scientific study of time is far from complete. Some physicists believe we'll need a new theory, perhaps a full unification of general relativity and quantum mechanics, to truly understand it. Until then, we stand at the frontier, peering into a mist of probability and paradox. But perhaps that's where the future has always been, not behind a locked door, but shimmering just ahead of our fingertips, waiting for us to remember it's already here. If the future is out there, and if time is a landscape rather than a river, then what does this mean for human perception? Why do we experience time as flowing forward rather than all at once? To explore this, let's consider the concept of the arrow of time, a one-way direction in which events seem to unfold. You drop a glass and it shatters, but you never see shattered pieces leap up and reassemble into a glass. This asymmetry is not dictated by the laws of physics themselves. At the microscopic level, most of the laws governing particle motion are time-symmetric. That means they work the same forward and backward in time. So why do we perceive a forward-moving now? The answer may lie in entropy, the measure of disorder in a system. According to the second law of thermodynamics, the total entropy of a closed system tends to increase over time. In simple terms, things tend to go from order to disorder. Ice melts, rooms get messy, stars burn out. This law is what gives time its familiar direction. But it also suggests something strange. The reason we remember the past but not the future may have more to do with entropy than with time itself. The past has lower entropy, so it's easier to encode and recall. The future, being more disordered, resists prediction. Yet this raises a puzzling question. Why did the universe start with such low entropy? The early universe, just after the Big Bang, was astonishingly uniform, smooth, and low in entropy. This initial condition is still one of the deepest mysteries in cosmology. If time's arrow is a result of rising entropy, and if entropy increases from a mysteriously low starting point, then the origin of the arrow is baked into the initial conditions of the universe itself. Some theories suggest this is just how our region of the universe began. Others propose more radical ideas, like time-symmetric cosmologies, models in which time flows in opposite directions on either side of the Big Bang. In one such model, the universe we know expands forward in time, while a mirror universe expands in the opposite direction. Inhabitants of that universe would experience their own arrow of time, opposite to ours, but they'd never know we exist. From the perspective of the whole cosmos, time may have no preferred direction. Only localized arrows emerge based on entropy gradients. This suggests something stunning. The flow of time might be a psychological illusion, an emergent property of how conscious observers organize memories and experience causality, which brings us to the role of the observer. In quantum physics, the observer plays a central role. A system can exist in multiple states at once, called a superposition, until it's measured. Then the system collapses into a single outcome. This isn't limited to particles. The entire universe could be treated as a quantum system, and your conscious experience might be entangled with a particular branch of its unfolding. This leads some scientists and philosophers to speculate that consciousness could be a mechanism for selecting a specific version of the future, not by forcing it, but by observing it into being. If this is true, then the future isn't something we approach blindly. It's something we co-create by the act of observing, choosing, and becoming. Let's ground this with a visual metaphor. Picture the universe as a vast library. Each book is a complete timeline, a whole life, a whole history, a whole future. You can't read every book at once, but by focusing your awareness, you flip through the pages of one particular story. You don't write the book in real time, you're moving your attention through a pre-existing structure, like a needle tracing grooves in a record. Still, your choices, what to notice, what to believe, what to desire, may shift which shelf you're on, which library you're in, or even which reality you inhabit. This is where information theory meets physics. Some theorists argue that information, not matter or energy, is the fundamental substance of reality. If that's the case, then reality may be shaped not just by particles and forces, but by how data is processed, transferred, and observed. The universe as a quantum computer is a serious line of research. In this view, the cosmos evolves like a giant computation, with each interaction acting like a calculation that updates the state of the system. And in any computational system, the outcome is affected by both the algorithm, the rules, and the input, the data. So what if your thoughts, emotions, and observations are forms of input? This doesn't mean you can control the universe like a puppet, but it does mean that you are part of the equation, part of the feedback loop that helps shape which future becomes real in your timeline. Let's connect this to the nature of time in quantum gravity. a theory that seeks to unify general relativity and quantum mechanics. In some formulations of quantum gravity, like loop quantum gravity, time disappears altogether. The equations don't include time as a parameter. Instead, what matters is how different parts of the system relate to each other. This suggests that time isn't a flowing substance, but a relational quality, a result of the way things interact. In these models, change still occurs, but there's no universal clock ticking behind the scenes. Instead, time arises as a byproduct of interactions. This fits with a more radical idea. There is no now in a cosmic sense. The present moment is not a special point in time. It's a point of view, a slice of experience in a landscape where past, present, and future coexist. So where does this leave us? If time is emergent, entropy-based, observer-dependent, and computational, then the future is not ahead of us on a conveyor belt. It's already part of the structure. We're just accessing it moment by moment through a kind of cosmic reading process. The future may not be out there in the traditional sense. It may be in here, latent in the architecture of reality, waiting to be experienced. This also gives new meaning to the human imagination. When you envision the future, you're not inventing something from nothing. You might be tuning in, resonating with, an actual possibility that already exists. And when you act on that vision, when you build, create, and move forward, you align your current trajectory with that potential future. The act of imagining becomes a form of navigation. Of course, from a classical perspective, this might all seem speculative, but even traditional physics now acknowledges that time is far stranger than once thought. Whether it's the relativity of simultaneity, quantum superposition, or holographic duality, our assumptions about time are constantly being challenged. So if you're wondering whether the future is real, or whether it's just a guess we make based on memory and habit, the answer may be it's both. The future is real in the sense that it is structured into the architecture of space-time, existing beyond your current perception. But it's also dynamic in the sense that your relationship to it changes based on choices, context, and observation. You don't control the future like a script, but you influence it like a painter, choosing which colors to use, which lines to draw, which story to highlight. In the final part, we'll tie all of this together, looking at how science, perception, and cosmic possibility shape the strange and beautiful question of what the future really is. Hello everyone, thank you for joining this journey into the mysteries of time and the future. As we come to the end, it's important to remember how deeply these questions touch not just science, but our everyday experience, our hopes, fears, and dreams. We've explored the strange and fascinating ways that physics, relativity, quantum mechanics, entropy, suggests that the future might already be out there in the universe somewhere. Whether woven into the fabric of space-time, encoded in quantum possibilities, or branching infinitely in multiverses, the future challenges our notions of linear time. But science also reminds us that our experience of time, the flow from past to present to future, is deeply tied to consciousness, perception, and the very structure of reality itself. This has a gentle and profound implication for sleep. Sleep is when our conscious mind rests, but the subconscious weaves through memories, emotions, and perhaps glimpses of what's to come. Dreams may be more than random firings of neurons. They could be moments where our awareness slips past the usual boundaries of time, touching the future in subtle, symbolic ways. When you lay down to sleep tonight, consider that you are entering a state where time's usual rules soften. Your mind might dance along the edges of the future, brushing against possibilities not yet realized. This perspective invites calm and wonder. It reminds us that time is not a prison, but a vast, intricate tapestry. The future is not a distant place to fear or control, but a horizon already drawn, waiting to be experienced. So sleep well, knowing that you are part of this cosmic unfolding, that each breath, each heartbeat is both a step forward and a thread weaving together past, present, and future. And when you wake, carry this knowledge with you, that the future, in all its mystery, is already out there, and you are moving through it, moment by moment, in beautiful, unfolding harmony. Thank you for watching Soft Science. Sleep peacefully, and may your dreams carry you gently into the possibilities ahead.